Hello everyone, so welcome to the channel. Today we are going to look at some logarithms problems. So most of them would be easy and we'll look at 7 to 8 questions. Some are difficult but we'll look at all of them step by step. The first question is very easy. It is just based on the basic understanding of the logs. So in the first part we have log 1 by 16 base 2. We can write 16 as 2 to the power minus 4, right? So it will be log 2 to the power minus 4 base 2. Now using the property of the logs, minus 4 would come at the beginning of the log. So it will be like minus 4 log 2 base 2. And log 2 base 2 is 1. So the answer is minus 4. In the second part, we have log 3 base 9. Now we can just use the base changing theorem to make it easier. So for this we can write we will take the base as 3. So log 3 base 3 by log 3 9, like log 9 base 3. Now log 3 base 3 is 1 while log 9 base 3 is 2. So the answer is 1 by 2. In the third part, we have log root 3 81. Now to bring it in the form of root 3, so that we just get a coefficient as the answer for this. So log root 3, we can write 81 as 3 to the power 4, right? And now we'll take, now we'll write in the form of root 3. So it will be like root 3 in 1 by 2 into 4. Yes, because 2 into 4. So it is like root 3 square is 3 and 3 to the power 4 is 81. Now 4 into 8, so 8 into log root 3 base root 3. This is 1, so our answer is 8 for the third part. Now for the next part, within the same question, we are given that log a base ab is 3. We need to show that log b base ab is minus 2. For this, we first have to use one of the properties, which I will restate here. So like we are given a log b base a. We can write it as 1 by log a base b. So this is one of the properties which you might have come across, but I restated it for your convenience. Now for proving this or showing this, we need to show that log b base ab is minus 2. For this, we'll simplify this. So we'll write as log ab base b is equals to minus 2. Now we'll not write minus 2, although I wrote it here by mistake, because we need to show this. We are not given this, or this is in the equation. So 1 by log 1 by log b base b plus 1 log a base b, right? Now log b base b is 1, so this expression becomes 1 by 1 plus log a base b. Now from the given expression that log a base ab is 3, we will find the value of log a base b, so that we are able to show this. Now we know that log a base ab is 3, right? So 1 by log ab base a is 3. Now log a base a plus log b base a is 3. The expression becomes 1 is equals to 3 plus 3 log b base a minus 2 by 3 is log b base a, and using the same property we will write it as minus 3 by 2 is equals to log a base b. Now we got the value of log a base b. So in this expression which we got here, we'll just take this value and put it in this expression so that the answer should come minus 2. Now 1 by 1 plus minus 3 by 2. Okay. Now 1 by 1 minus 3 by 2. It is minus 1 by 2. So the answer is minus 2. So the first part is complete. We had shown that this is equal to minus 2. Now in the next part, we need to find the value of log this base AB. So this is very easy. We have all the value. We just need to plug it in. So log, we write the part here, log root cube root of a by square root of b base ab. So we're using the property of logs. We can write log cube root of a base ab minus log root b base ab. All right. Now it is, if we see it clearly, it is just a to the power 1 by 3 base ab minus log b to the power 1 by 2 base ab. Now it becomes 1 by 3 log a base ab minus 1 by 2 log b base ab. Now log a base ab is 3, we know this value, minus log b base ab is minus 2. So 3 minus minus 1 is equals to 4. So the answer of this part is simply 4. Okay, so we now know all the answers. So the first part is minus 4, second part is 1 by 2 or 2 to the power minus 1, and next part is 8. And we were able to show this, and we found the value of this. Now we'll look at the next problem. Now for the next problem, we have a logarithmic equation. Now in equation, focus firstly that the basis of all the logs are the same. Okay. Now in this problem, we see that 3 is a common base in all, but just in this middle, uh, like middle expression 1 by 2 log 3 base 2, we don't have base as 3. Now we can just make the base 3 by using one property which I told in the previous question. So it is like log root x base 3 is equals to log 2 base 3. I can write this as log 2 base 3 by 2, yes, plus log 4 into x cube base 3. Now for simplification of this log, in which 4x cube is given, we can write this as, so log x 1 by 2 base 3. Now on LHS, let's simplify it first. So it is half log x base 3, okay, is equals to log 2 base 3 by 2 plus log 4 base 3 plus log x cube base 3. Now log x cube base 3 we can write as 3 log x base 3, yes, so 3 log x base 3 plus log 4 base 3 plus log 2 base 3 by 2. Now to make this equivalent, we'll multiply uh, these two terms by 2 so that the 2 cancels out. Okay, now log x base 3 is equals to log 2 base 3 plus 2 log 4 base 3 plus 6 log x base 3. Now it becomes log x base 3 is equals to log 2 base 3 plus log 4 square base 3 plus log x power 6 base 3. Now it's very simple now. Just go further. Now log x base 3 is equals to log 2 into 4 square into x power 6 base 3. Now log, now we have the same basis. We can equate x is equals to 2 into 4 square into x power 6. Yes. Now 1 by x power 5, because x by x power 6 is 1 by x power 5, is equals to 2 power 5. Okay, now 1 is equals to 2 power 5 into x power 5. So we can write 1 by 2 whole power 5 is equals to x power 5. So here we get x as 1 by 2, and it satisfies this condition that x is greater than 0. So this was a very short problem, but as we did all the steps, it just is looking huge. But it's very simple problem, right? So x is 1 by 2 in this problem. Now in the third question, we have two equations, or the simultaneous equations. We need to find the value of x and y. Okay. Now in the first equation, we have log 6x base 2 is equals to 1 plus 2 log y base 2. Now we again need to keep in mind that bases are the same. Now log 6x base 2, we can write one as log 2 base 2, right? Plus log y square base 2. Yes. Now 6x is equals to, oh yeah, so log 6x base 2 is equals to log 2y square base 2. Now since the bases are the same, we can equate 6x is equals to 2y square. Yes. Now we know this from the first equation. In the second equation, we have 1 plus log x base 6 is equals to log 15y minus 25 base 6. Now we need to make the bases same, or need to make the base as 6. Now we can write one as log 6 base 6 plus log x base 6 is equals to log 15y minus 25 base 6. Now from this we can write log 6x base 6 is equals to log 15y minus 25 base 6. Now since the bases are again same, 6x is equals to 15y minus 25. Now from this value, we can take 6x as 2y square, right? So 2y square is equals to 15y minus 25. And now it's just a quadratic equation. 2y square minus 15y plus 25 is equals to 0. 2y square minus 10y minus 5y plus 25 is equals to 0. 2y, y minus 5 minus 5, y minus 5 is 0. So we got y as 5 by 2, or y is equals to 5. Now we just put the y value in this and we get the value of x. So if y is 5 by 2, x is 2 into 25 by 4, because 5 by 2 square is 25 by 4 into 1 by 6. Now so x is 25 by 12. Now if y is 5, then x is so x becomes 25 into 2 by 6. Yes, so x is 25 by 3. So that's how we solve these simultaneous problem equations. Now for the fourth question, we again have an equation. This time we have ln. Now some of you might be familiar with this concept, but I'll explain this. So ln is nothing, it is just log of something, say a, to the base e. Now what is e? E is a Napier's constant. You might have read this, and approximate of e is around 2.77. Okay, so we write log something base e is ln a. Okay, ln of a is log of a base e. Now in this we have 2 ln x, and the properties are same for this, but this is log, it's nothing new. Now ln 2 ln x is equals to ln 9 plus 4. Now ln x square minus ln 9, we took this here, is equals to ln e to the power 4, because log e to the power 4 base is 4, right? Now ln x squared by 9 is ln e to the power 4. Now we can equate this, x squared by 9 is e to the power 4. X squared is equal to 9 e to the power 4, so x is just root of this, and we can write this as plus minus 3e square. Now we have two values. We'll discard this negative value because anything raised to the power something cannot be minus, cannot be negative at all. That's why we discard this value. So the answer of this part is 3e squared. So x is 3e squared, and this satisfies this form p e power q. So p is 3, q is 2. Now we have two more problems, fifth and sixth. So fifth is pretty easy. I think that some of you must solve it in your minds. On this we have log n base m into log m square base n. We can just bring 2 here. Now log n base m into 2 log m base n. Now we can write log m base n as 1 by log n base m to make them both equal. So log n base m into 2 by log n base m, these two cancels out. So our final answer is 2. Okay. Now in sixth question we again have an equation. Now 2 power 4 by log 4 base 5 plus 3 by log 8 base 7 is equals to 175. Now we take the log on both the sides with the base 2. So log 2 power 4 by log 4 base 5 plus 3 by log 8 base 7 is equals to log 175 base 2. Now we're the same. Now in this we can bring this whole thing here. So 4 by log 4 5 4 base 5 plus 3 by log 8 base 7 is equals to log, yeah, so wait, we didn't take log 2 base 2 though, because it is equal to 1, but we can just write it whole multiplied by log 2 base 2, which is just 1, is equals to log 175 base 2. Now 4 by log 4 base 5 plus 3 by log 8 base 7 has to be proved log 175 base 2. Now this is already simplified, we can't simplify it further, so we can just leave the RHS and focus on this LHS. So on LHS, 4 by log 2 square base 5, we can bring 4 in the form of 2 plus 3 by log 2 cube base 7. So 4 by 2 log 2 base 5 plus 3 by 3 log 2 base 7. 3 cancels out, 2 times 2 4. So 2 by log 2 base 5 plus 1 by log 2 base 7. Now to make the bases equal, we have 2, so we can just use that property again. Log 5 base 2 plus log 7 base 2. We can bring this 2 here, so log 5 square base 2 plus log 7 base 2. So it becomes log 2 5 square into 7. Now 25 into 7, it's just 175. Now this is LHS, and now from LHS, and this was our RHS. Now LHS is equals to our RHS, hence showed. that. What was the question? Yeah. So 2 4 by log 4 base 5 plus 3 by log 8 base 7 is equals to 175. Okay. So this problem was these problems were easy. Yes. Now let's take one last problem for the today's video. So this is again simple. Just last part may face some problems. Now in the first part, we have by evaluating each expression when x is equals to 9, show that these are not equal, always equal. Now log x base 3 whole base 9 and log x base 9 whole base 3. Now we just plug in, like, put the value of x is equals to 9 both the expressions. So log of 9 base 3 whole base 9 and log log 9 base 9 whole base 3. Now log 9 base 3 is 2. Yes. So log 2 base 9 and here log 9 base 9 is 1. So log 1 base 3. Now this is nothing but 0 because anything raised to the power 0 is always 1. Now log 2 base 9 is not equal to 0, hence prove or showed that these are not always equal. Now find the value of x such that log of this is equal to log of this. And this is just same expression. We need to find the value of x that is originally makes them equal. So in the second part, log x base 3 whole base 9 is equals to log x base 9 whole base 3. So first of all, we make the base same as usual we do. So log 3 base log x base 3 by log 9 base 3 is equals to base is always equal, so don't need to change this RHS. So log x base 9 whole base 3. Now this is 2. So log x base 3 of 3 by 2 is equals to log x base 9 whole base 3. Now we got the coefficient as 1 by 2, so we can write log root of log x base 3 whole base 3 is equals to log x base 9 whole base 3. Now we can just equate root log x base 3 is equals to log x base 9. Now squaring on both the sides, we get log x base 3 is equals to log x base 9 whole square. Now we again need to make the bases equal. So in this we can write log x base 3 is equals to log x base 3 by log 9 base 3. It is again 2. So log x base 3 is equals to log x base 3 whole square by 2 square, which is 4. Now 4 log x base 3 is log x base 3 whole square. Now we can take log x base 3 is equals to p. So it becomes 4p is equals to p square. So p square minus 4p is 0. It again became a quadratic equation. So p can either be 4 or p can equal to be 0. But p can't be 0. Now the logic is that if we put 0 like here, so uh, like it just becomes undefined. Okay, so p can't be 0, and because anything raised to the power something is always positive, can never be 0. So p is equals to 4. Now log x base 3 is equals to 4, or log x base 3 is equals to 0. Let's see what happens if we put this as 0. uh, yeah, we can solve it. Yes, yes. So log x base 3 is equals to log 1 base 3, so x comes out to be 1. But now here again a problem arose. If we put x as 1 here, it becomes 0. Now log 0 base to the 9 is nothing, it's just undefined. So again we have to discard this value anyways. And if we put it as log x base 3 is 4, so the answer comes out to be x is equals to 3 power 4, which is nothing but x is 81. I've understood the logic that why we didn't take x as 1 after after solving the value p as 0. So the answer for this is 3 power 4, which is equals to 81. Now we have a third part in which it says that find in terms of a the solution to log a x base a whole to the base a square is equal to log x base a square whole to the base a. Now it's just nothing but the same part but in the variables. So we'll solve this. Log x base a square base a square is equals to log x base a square base a. Now from this part we will just take some of the inferences which we made it. Now here log of log x base a, we can write this as half of this. Like in this part we change the base and got this. Yes, so suppose a is 3, so in this also we had 9 in place of a square. Now then we wrote it as half into log a x base a, which is same similar to this, right? And in this we have log x base a square a. Now we took this root here, so root of log x base a is equals to log of x base a by 2 again. We took this because we have this log x base a square, so we just wrote it like this in this form. And from here if you people are checking, we are getting some property, right? We can make some property, like if we have something like this, log x a to the power n. Yes, so we can write this just as log x base a by divide by n, because if you see in all the forms n is always coming out to be the in the denominator of each log. If you have checked all the questions, if we change the base then it is just same as this. So this property we'll be using from now on in the questions to make our work easier. So squaring on both sides to remove the square root, we can write this as log x base a whole square by 4. So again, we're taking log x base a as, say, log x base a as q. Now 4q is equals to q square. Now q square minus 4q is equals to 0. So q can be 4 or 0. But again, using the same argument that here we can't place a 1, otherwise it becomes undefined. So q is 4. So log x base a is 4. So x is just a to the power 4, right? So we get a to the power 4 here. Now for the last part, we just have the same question, just the power is in the form of variable. Now we need to show that both sides of the equation have this value. Alright, so let's start with this question. The last part. So fourth is log of log x to the base a whole to the base a raised to k is equals to log x to the base a raised to k whole base a. Now from previous parts we can take log x base a whole to the base a by k is equals to log x to the base a by k whole base a. Now log of log x to the base a raised to 1 by k base a is equals to of log x to the base a by k into base a of base a. Yeah, so log x to the base a raised to the power 1 by k is equal to log x to the base a divided by k. Now let's take log x to the base a as y for easy expression. Yeah, so y to the power y to the power 1 by k is equals to y by k. Now raising by k on both the sides, y is equals to y power k by k power k. Now y into k to the power k is equals to y to the power k. Now y to the power k minus y into k to the power k is equals to 0. Now y into y to the power k minus 1 into k to the power k is 0. So we get y is 0, or y to the power y k minus 1 is equals to k times k power k. Now we need the value of y here, but we have the power k minus 1, so to remove it, we'll raise both the sides by 1 by k minus 1. So y k minus 1 multiplied by 1 by k minus 1 is equals to k to the power k times 1 by k minus 1. So y is k to the power k by k minus 1. Now we take this value and put it in the original log. So log of x base a is k to the power k by k minus 1, right? Now further going up, we have the we have the value of log x base a. So we'll just take this value and put it in one of the sides. We'll take our LHS for instance. So log k to the power k by k minus 1 to the base a times a power k. Now on LHS we are taking now log of k power k by k minus 1 base a by k. Now we'll raise it to 1 by k on the k of the base of the log. Yeah, so log k raised to k by k minus 1 into 1 by k. We just used this k as the coefficient and took it here and multiplied it, okay, to the base a. Now log k raised to 1 by k minus 1 base a, and this is what we needed to show in the question here. So log k to the power 1 by k minus 1 whole base a. So here you can clearly see that on LHS we got this value, and hence both the values are, since both the values are equal, it is given that when this is equal to this, then both sides of the equation have this value. Hence they should. And this was the end of today's video of the logarithm problem solving. In the next video, we'll come up with more logarithmic problems and some interrelated concepts such as polynomials and logarithms are interconnected. So we'll look at those kind of problems. And I hope you understood everything in today's video. And for any queries, you can always reach out to me. And if you like this video, please like, share, comment, and you can all comment what you want in the next video or your doubts. You can always reach out to me on my email ID, which is mentioned in the about of YouTube channel. Thank you for seeing this video.